Hello again. In this video, we're going to introduce the definition of a derivative as a function. Now, in previous videos, we did talk about the derivative of a function at a fixed point a in the domain of the function f of x. So, for example, if this is the graph of some function f of x, and this is some fixed point in its domain, call it a, then f prime evaluated at a, the derivative evaluated at a, is simply the slope of the tangent line at this point A. And so in this case, you can see that the slope of this tangent line is a positive. So f prime evaluated at A, the derivative evaluated at A would be a positive number. And by the way, that's also equal to the instantaneous rate of change in the function at this point A. All three of these are equal to each other. Okay? So the slope of the tangent line at A is equal to the instantaneous rate of change in the function at A, which is also equal to the derivative evaluated at A. Okay, now if you move this fixed point to a different location, so maybe over here, then of course the derivative at A is different. You can see the slope of this tangent line is actually negative. Okay, and so what we want to do is come up with a function which describes the derivative at any point in the domain of this function, f of x. Okay, and that function is called the derivative. So essentially the derivative as a function is going to describe the slope of the tangent line to this function at any point in the domain of the function. Okay, and here's how we're going to come up with it. We're going to start with our definition of the derivative evaluated at a. So if you remember, f prime evaluated at a was equal to this limit. And all we're going to do is we're going to say, okay, this a is a fixed point, but we want it to be a variable. And so we're going to replace the a with the variable x. And so after we do that, it will look like this, right? It will be f prime of x instead of a is equal to this limit, and then instead of f of evaluated at a plus h, it's going to be f evaluated at x plus h, and then minus f of x instead of f of a. Okay, so this is now called the derivative of f. And it's a function, right? It depends on this variable x. So it's a new function. And of course, we denote it with a prime, just like we did here. Okay, so the derivative of f is this function, f prime of x, and that's equal to this limit, provided the limit exists. Sometimes limits do not exist, okay? So provided the limit exists, and also provided that x is in the domain of f. Okay, the derivative is only defined for x values that are in the domain of the original function f of x. Now, if the derivative exists, we say f is differentiable at x. So if f prime of x exists, then f is said to be differentiable at x. And if f is differentiable at every point in an open interval I, then we say f is differentiable on the interval I. Okay, so what I want to do now is maybe just do an example where we find the derivative of some function. Okay, so let's take example 1. Let's try to find the derivative of this function. Okay, so this is our definition of the derivative as a function. And so we're going to use that to find the derivative of this function. Okay, so f prime of x, and again, we denote the derivative with a prime. Okay, is simply this limit. And we need to find f evaluated at x plus h. So I'm going to find that on the side. Okay, so this means we have to plug x plus h into this function, okay, and see what comes out. Now I'm going to write this kind of in a shell form because it makes it easier to see what happens. When you evaluate this function at some number, you plug that number in here, and you plug that number in here. But the number we're evaluating the function at is actually this number. So I'm going to plug that in here, and then you get x plus h squared with a minus sign in front of it. And then you also have to plug it into here, right? But the number we're plugging in is actually x plus h. Okay, so that's what you get out when you plug x plus h into this function. Of course, now I've got to FOIL this out. Okay, so let's FOIL that out on the side. Now remember, x plus h squared means x plus h times x plus h. So you do have to FOIL this. Okay, so the first would be x squared. The outer would be x times h. And then the inner would be h times x, but the order in which you multiply doesn't matter. So I'm going to write that as xh. And then the last, of course, would be h squared. Okay, so going back to this, you have a minus sign in front of that. And then we can go ahead and write this as 2xh's. Okay, so this is what we get when we FOIL this out. But again, there's a minus sign in front of this, so I have to put parentheses around this because I'm subtracting this entire thing. Okay, and then here I'm just going to distribute the 6. Okay, so you get 6x plus 6h. And then I'm going to go ahead and distribute this minus sign. Okay, and so that's what we get for this piece here. Okay, so I'm going to write that up here. So you get minus x squared minus 2xh minus h squared plus 6x plus 6h. Okay, and then we're going to subtract off f of x. But of course, f of x is just equal to this. So subtract all of that. So I'm going to put that in parentheses. Now, of course, when you subtract this off and you distribute it to both of these, that's just going to change the sign of both of these terms. So I'm going to go ahead and do that now. So this is going to become a plus, and this is going to become a minus. But make sure you distribute it to both. Okay, so this is going to turn into a plus, and this will turn into a minus because you're distributing a negative sign to both of them. Okay, and then all of that is going to be divided by h. Okay, so now let's see if we can't cancel anything. So this negative x squared would cancel with the positive x squared. And then the positive 6x cancels with the negative 6x. Now, let me just mention this. This f of x, whatever's over here, every single term in this function needs to cancel out with some terms over here from this function. If that doesn't happen, then you're doing something wrong. And so notice that happened here, right? Both of these terms from f of x have canceled out with terms over here. Okay, so make sure these cancel out. The reason that has to happen is because everything that's left over has to have an h in it in order to cancel this h on the bottom. Okay, so if I'm left with like x squared here, let's say that didn't cancel out, then I wouldn't be able to cancel this h on the bottom because this would have to have an h in it. But notice here I am left with 3 terms on top that all have an h in it. Okay, and so for that reason, I can cancel the h on the bottom because this h divides all 3 of those terms. Okay, so you're just left with negative 2x here. You're left with 1h on top here, so minus h. And then these 2 h's cancel, and you're just left with plus 6 here. Okay, and we want to find the limit of this as h goes to 0. By the way, I should have mentioned this earlier. You can try direct substitution right now to evaluate this limit, but notice you'll get 0 over 0. So this form right here is indeterminate. But once I cancel this h out on the bottom, then it becomes determinable. And when I use direct substitution now, right, when I plug 0 in for h now, I get negative 2x plus 6. Okay, and so this is the derivative of this function. So f prime of x, the derivative of f of x, is simply negative 2x plus 6. Okay, and then just to finish this off, what does this function tell us about the original function? It tells us several things. The first thing it tells us is it gives us the instantaneous rate of change in this function at any point x in its domain. It also gives us the slope of the tangent line at any point to this function. Okay, and then it also gives us the derivative evaluated at any point. Of course, that's obvious, I guess. But remember, those three things are equal, right? F prime at A at a fixed point A is the slope of the tangent line at A, and that's equal to the instantaneous rate of change in the function at A. Okay? Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.